Alright, so in this video, we're going to look at the same thing again, exact differential equations with integrating factors. Last video ended up being a lot longer than I thought it was going to be, so I did it the long way, right? So now, in this video, I'm going to go through two examples here. I'm not going to do 18, and I'm not going to do 20. I'll do 19 and 21. And I'm going to do them both ways. So I'm gonna solve for mu both ways, right? So let's start with 19 here. I'll do the long way first. So let's just show that it's not exact though. So 19 we have y prime is equal to e to the 2x plus y minus 1. Okay. So yeah, so this is our m, right? That's m. Yeah, that's m. So this, we have e to the 2x plus y. Actually, minus e to the 2x minus y plus 1 plus y prime is equal to 0. So yeah, this will be 1, I guess. So then we have our m and our n. Now, m with respect to y is 0 minus 1 plus 0. N with respect to x is 0. So it's not exact, right? So that tells us that we need to find our integrating factor, right? So that it is exact. So now, we're going to multiply mu by both m and n, right? This is the long way. Okay, so I'll do it the long method. The long method, okay. So we have mu. Remember, mu is a function of x, right? Mu times, what is that? Negative e2x minus y plus 1 plus, that's just mu y prime, right? So we know that my has to equal nx. So then that tells us that, excuse me, okay, my would become, this is Tweedle, by the way. Remember, this is our new m and our new n. So we have our new m with respect to y. Also, I should write it out like this with respect to x, because this is actually important for this step. Actually, we don't even need to do the product rule for this one. This one's easier than the last example in the last video, right? So we have m of y is equal to n of x. Well, this just stays out front, right? Because it becomes a constant. This will become 0 minus 1 plus 0 is equal to n of x. That's just going to be mu prime of x. So I'll just write it as mu prime. I'll just rewrite this. So this right here, this is all we need. I honestly prefer the long method. Wow, this is so much easier, isn't it? Right from here, we just do our separable equation. So we have mu times negative 1 is equal to, that's d mu dx, right? This is with respect to x, I think. Let me think about this really quick. This is number 19, right? Yeah. Let me think about this. Yeah. What I have here is right. Is that with respect to x though? I forget. I'm trying to think of the formula here. If we had, that will be that'll be yeah, it's with respect to x. Okay. I'll show you why in a second. So when I do the formula method, so this will leave us with mu. Well, integrate both sides, right? This will become negative x. This is with respect to x, and that yeah. So this is with respect to x. Oh, I forgot to separate it. Hold on. I forgot to separate it. I was like, that doesn't work. So we have d mu over mu is equal to negative 1. Well, no, that yeah, just negative dx, right? Integrate both sides. The natural log of mu is equal to negative x plus c. We assume c is 1 though, right? Okay, so then we have ln of mu is equal to negative x. Exponentiate both sides. Mu is equal to e to the negative x. There's our mu, and that is the correct answer for mu. But now, let's remember our formulas now. So now let's do the formula method. Let's look at the formula method. So let me write down the two formulas, see if I remember them. So we have mu prime. Let's see if I have these written down somewhere here. Oh, I do, okay. So we have mu prime is equal to my minus nx over n. And this is if we are independent of y. So in terms of x. So terms of x terms of y. That's nx minus my over m, I think. Let me just make sure that's right. Yep. So this is our two formulas. This is in terms of x, that's in terms of y. So now let's go back. Let me copy this. Let me copy this whole section right here actually. Okay. So we're back at this point now. Forget about the log method. Let's look at the formula method. So not exact, right? So now let's look at this. Looking at our two formulas, right? Can we so we need it either in terms of x or in terms of y. We have to eliminate one or the other. So looking at these formulas, looking at just focusing on this section right here. Just focusing on this section. So which one would cancel out x? Which one would cancel out y? Or you're right. So we have, if we so we have our my and our nx, right? So looking at these, it doesn't matter which formula we use, does it? Oh wait, yes it does. Okay, well let's do this. I'm gonna do this. I'm gonna do both formulas, and I'm gonna show them what would happen if we use both. So if we use the terms of x1, this is the good one, by the way. We know this is gonna work because we just did it the long way and it was in terms of x. But anyways, my is -1, and x is 0. N is 1. That eliminates x and it eliminates y. Right? This is what we had before, right? That -1 we had right there. That's what that is. That's where we get that from. See, the formula can be faster, but it just requires a little bit more thought, though, in my opinion. That's why I never actually did it the long method. I kind of like it. See, it's really not that much extra work. It's really not. I wish I knew this when I was in the class, the log method. But okay, let's look at the terms of y1 now. If we take nx 0 minus my, so that's plus 1, over m, and you'll immediately see the problem here. We didn't isolate y from x or x from y, right? We have x and y in that equation, so obviously that's not going to work. So if I use this down here, it doesn't work, right? So now let's plug this back into here now. So now we have mu prime is equal to -1 times mu. And just like before, I'm just going to skip all the steps because we did this whole thing before, right? So that we got mu is equal to e to the -3x. Oh, not -3x, negative x. Now that we have our mu, we can go ahead and solve the exact equation. So let's go ahead. This part's still the same. We still multiply our m and n by mu and we get our new n and our new m, right? So we're going to have e to the -x times, oh, it's right there, negative e to the 2x minus y plus 1 plus e to the -x times y prime is equal to 0. So yeah, so now this is our new m. So this is our m twiggle. M twiggle. Let me draw the box first. M twiggle and n twiggle. So now, just like before, my, let's see if it's, hold on. I gotta simplify this first. E to the -x times negative e to the 2x is, excuse me, is just e to the yeah, what the hell did I do over there? E to the minus, yeah, that's right. Doesn't that should become minus e to the x? Why do I have e to the minus x there? That's not right. Let me check that really quick. Oh no, I'm good. When I initially did it, I had them in a different order. That's all. So this will be yeah, minus e to the x minus e to the -xy plus e to the -x. Yeah. And then that's plus e to the -xy prime. Oh my god. Yeah. Okay. This is our m twiggle. This is our n twiggle. M twiggle. N twiggle. Okay. Now, let's solve for my twiggle. First term 0, second term negative e to the -x, third term 0, and x. That's just, remember, the derivative of e to the -x is negative e to the -x. So we successfully, I just spelled exact wrong. We successfully made it exact. Okay. Now, let's start with which one would be easier to take the integral of. Obviously, n twiggle, right? So that's our, remember from the last video, that's our d phi dy is equal to e to the -x. Integrate both sides. Phi is equal to y e to the -x plus h of x. I'm sorry, h of x. This is a y. H of x. Now we did y already, so let's do x. This would become negative y e to the -x plus h prime of x. Set that equal to negative e to the x minus e to the x times y plus e to the minus x. Does anything cancel? Yeah. No. Oh, yes, it does. I miswrote that down. These cancel. H prime of x is equal to negative e to the x plus e to the negative x. Integrate both sides. H of x is equal to, this one's with respect to x, so this will become negative e to the x minus e to the negative x plus c. I'm going to keep that plus c in there. If you remember that last video, I had a tough battle with that plus c. Okay, so now we plug that back into our phi, right? So y e to the negative x minus e to the x minus e to the negative x plus c is equal to 0. We subtract that c over. Right? It becomes a new constant. So, if you were confused with what happened after I made it exact, go back to my last video, because I kind of sped through that. Go back to my last video, watch it. It'll cover all this stuff. So yeah, just remember, if this was an IVP, we can continue this on. We can solve for C, and then right, and then we have our different solution. So this is our general solution. It only took 17 minutes, right? Now let's go through this next one a little faster. So let me see here. 21. Let me get my notes. We have y plus, okay, so we have y plus, this is 2xy minus e to the 2y. I can't read my own handwriting. Let me see if that's right. E to the minus 2y, yeah. Okay. Is equal to 0. So, excuse me. So we have our m and our n. Is it exact? Just by looking at it, it's pretty obvious that it's not, but let's just check. My would be 1, and x would be, that's 2y minus 0, so that's 2y. Not exact. Let's find the integrating factor. So let's see if I remember how to do this the long way. So long way. We know that my has to equal nx. Well, first of all, let's write this out. We have to multiply mu by everything. Right? So now that's a mu. That looks awful. Okay. Excuse me. So now, right, my has to equal nx. So my in this case, I have to look back at my notes. Right. Let me. These are functions of x. Okay. This is unfortunate. We're gonna have to do the product rule for this one. This one's gonna be a little longer. Our my would be just, I guess that's just that's just, okay, yeah, that's just mu of x, I think, yeah. Just mu of x is equal to, or just mu. Now this right side here, this is gonna be a little more difficult. So we're gonna have this first times the derivative of the second, or I'll do it this way. The second times the derivative of the first, right? So we have mu prime of x times 2xy. Let me move this over so I get some more space. Okay, so minus e to the negative 2y. Okay, plus the first times the derivative of the second with respect to x, right? So this would be 2y minus 0. Oh, that's nice. That works. Okay, so let's look now. So what do we do next? I forgot. All right. Now, if you call back to my last video, these will combine. And we have mu of x minus mu of x times 2y. So this will become mu of x on the outside of, that's 1 minus 2y, is equal to mu prime of x times 2xy minus e to the minus 2y. Let's divide that over. And I'm just going to remove that x. I'm going to remove the x's here just to simplify this. Mu times 1 minus 2y over 2xy minus e to the minus 2y. Okay, so if have I made a mistake somewhere? Oh no. What should mu equal? Let me look. Where's my notes? Mu should equal e to the 2y over y. Did I mess up somewhere here? X was 2y. Yeah, that worked. That's our wait, how did I end up doing the wrong formula? I basically used like the wrong formula for this. I should have did it the other way. How does that work? So basically I treated it as if it was with respect to x, right? But we want to do it the other way with respect to y. So apparently I was doing it backwards there. What's the difference for that one? Give me 1 sec. Oh, no, okay, I see what's going on here. I now realize why I used to do the formula method. There's no way of really knowing which way you have to do it until you get to this point. And then you're like, oh no, this doesn't work. We don't isolate it, right? So then you have to go back. You have to go back and redo it with respect to y. So now we have mu with respect to y. Right, I think. That should be a y. Yeah. Okay, I see now. Okay, so now if we do the same thing. Okay, I see how this can take a while now. If you weren't right on your first guess, then yeah. Okay, I do actually recommend using the formula method. Okay, so, oh man, okay, so we'll have, this time, we have to do the product rule for for both sides. This is really ugly, isn't it? So we have mu of y. Oh man. We have mu of y times y. Wait, well, let me do this. Second times the derivative of the first. Times the first. Oh, wait. Derivative of the first times the second, plus the first times the derivative of the second, which is just 1, is equal to n of x. Oh, actually, no, you don't have to do a product rule for this side. So we'll have 0. No, that can't be right. Oh, yeah, that just becomes a constant. That's right. This is just a constant. Take that out. This will become, with respect to x, 2y minus 0. Okay. So that's it. Okay, this isn't too bad. I'm just not used to doing it this way. Well, yeah, let me rewrite this. So we can move that mu over. So we'll have mu prime of y times y is equal to, if we move that over, that's 2y minus y. Shouldn't that be 1? Oh, that's just minus mu of y. Yeah. Oh my. Okay, I'm getting confused by these. So let me just rewrite this as mu prime, mu, and this is just mu. Okay, so now we have this. Yeah, that's 2y minus 1. So this would be left with 2y minus 1. Right? If I move that mu over. And then we could simplify this to the form that we want. So I'm going to go right ahead and do this. D mu dy, this time it's d mu dy, is equal to 2y minus 1 over y times mu. Separate. Yep, we separate. How would we separate this? Can we? Yeah, we can. What am I talking about? Of course we can. Yeah, this is just a little bit uglier, I guess. Yeah, well, it's alright. So we have ln, take the integral both sides, natural log of mu. We're going to have to set, you have to do u sub? No, I don't think so. We just, no. This is just becomes, okay, let me rewrite this, actually. This ain't too bad. This just becomes, I'm getting a little tired here, you can tell, minus 1 over y. It should be, yeah, like this. So then this would become the natural log of mu is equal to 2y minus, this is, let me think, y to the negative 1, take the integral of that. That becomes plus y to the negative 2. That's not how that works. Now I'm forgetting how to integrate. It's getting late for me here. 2y minus this, yeah. You subtract 1 in the, no, you add 1. What am I talking about? Oh, yeah, that's just the natural, oh my, jeez. I'm sorry. That's how you really know I'm getting tired. Yeah, okay. Now we take the, that's the absolute value. We take the exponential of both sides. Mu is equal to e to the 2y minus the natural log of y. So then mu, yeah, that's our mu. Let's oh, we can simplify this, right? Yeah, we can simplify this because this is mu is equal to e to the 2y minus, well, I guess times e to the negative ln of y. So then mu is equal to e to the 2y times negative ln of y. Right? Oh no, that just becomes y, right? That just becomes y. I'm sorry, negative Well, y to the negative 1, right? Okay. So let's look back up here. Where's our original function? Oh, I have it written down over here. Okay, so y times, so if we have e to the 2y times y to the negative 1 times y plus e to the 2y y to the negative 1. Oh, wait. I promised I'd do the formula method, right? Okay, so the way I remember the formulas, if for respect to x, so with respect to x, I remember them as being, like you think of it, you write the x term down first. It's always nx and my, right? So you write the nx term first. That's how I remember these. So like if we have mu prime is equal to mu times, you write the nx term first with respect to x. And then for y, with respect to y, we start with y. So my minus nx over, and then you do it over. So since n was last up here, we divide it by that. M was last over here, we divide it by that. Okay. So let me copy what we had before. Where is it? Right here. And let's paste that. Let's see. So what could which formula would make more sense in this case? Could I remove the y's or could I remove the x's? Well, let's look. If we look at the first equation, we'll have nx minus my, which is 2y minus 1 over m over y. That can work, right? That can work. And wait, then we'll isolate with y. Wait a minute. Okay, it doesn't actually matter. What am I talking about? Yeah, it doesn't. These are just two formulas that we have. We can use either one of them. They don't necessarily say that one's going to be specific to y and one's going to be specific to x. It just depends on the problem. So for this problem, this first one works because because we can isolate them by having 2y minus 1 over y, right? We're left with just y. That isolated, where in terms of y, it worked out very nicely. We saved us, this only took what? Not even half a page, and I wrote pretty big here. And this took a whole, just to get, I did it with x first, right? So I did it with x first, that's almost a whole half a page, and then this way here was another whole half a page probably. So that saved you almost a half a page, or at least like almost half a page of work. So doing it the formula way. So I actually recommend doing it the formula way. It does save a lot of time, but it's good to understand like where the formula comes from. And I showed that in the last video, and you can kind of see how it worked out in this video as well. I mean, in this example up here as well. Okay, so now that we have this, let's look at the other one. Let's see why doesn't the other one work? Well, we'll have what? That's 1 minus 2y over 2xy minus, see that 2xy right there? That messes it up. That 2xy, you should easily be able to look at this equation right here and just be able to tell which one we need to divide it by. And that, like, if we have a term that has both of them in there, it's very rare that they will cancel out, but they could, but it's very rare. So we want to just you can tell it's divide by y. Look, we have a y here, a 1 there, so we only have y's here. We need one that only has y's. Look at that. This one has an x, no good. Okay, so now this is the same thing we did before. So our mu was e to the 2y times y to the negative 1. So let's multiply mu by our original equation. So I'm just going to go ahead and do it. So if we multiply mu by our original equation, we'll be left with e to the 2y plus 2x e to the 2y minus 1 over y times y prime is equal to 0. That's where we get it from multiplying mu by our original function. And then we can now solve this because we know it's exact now. Let's go ahead and prove that it is exact. So we have m of y, m tweedle y is equal to, that's 2e to the 2y, and tweedle x is equal to 2e to the 2y. So it's exact. I'm going to obviously do phi with respect to x first, right? Because that's so much easier than the other one. It's one less term. Not that much easier, but you know, it's one less step. That'll be 2e to the 2. I think that's just 2. Oh, it's 1 over 2, right? There might be. Oh, no. It would be if it was with respect to y, but we're with respect to x here, right? X e to the 2y plus h of y. Now, we do it with respect to y. That'll be 2x e to the 2y plus h prime of y is equal to 2x e to the 2y minus 1 over y. These cancel, thank God. H prime of y is equal to negative 1 over y. Integrate that. H of y is equal to negative ln of y plus c, right? So now we plug that in for phi x e to the 2y minus ln of y plus c is equal to 0. That leaves us with x e to the 2y. We can simplify this, right? This becomes, and we subtract that c over, it becomes a new constant. Right, it becomes negative c, becomes a new constant. And this is our general solution. Okay, so once again, after realizing that it actually could take, you can end up doing it the wrong way the first time you do it the long way, so then you have to do it again. So I can understand how the formula method could definitely save you like at least 5 minutes or 3 to 5 minutes, right, of your time. That's especially very useful on exams. But it's good when you do your homework, do it both ways, right? Do it both ways. Then you can get the practice of doing it both ways, because it's still good to know. But definitely for like a quiz or exam, just do it the formula way, if your professor allows. My professor was kind of strict on some things, but he did allow us to use the formula method. So yeah, that's that. And I hope you enjoyed the video. And this is, I guess, the last video for the first order ODEs. And now we'll be moving on to, I believe, second order ODEs, right? So they're not too bad until we get to the higher order stuff. All right, hope you enjoyed the video.